Hello, my name is Pantelis and welcome to this presentation on linear regression, connecting data with predictions. Let's begin with some fun facts. Did you know that when linear regression was first introduced 150 years ago, the primary mode of transportation was this guy? Now, linear regression has evolved to become a foundation for predictive models used everywhere, including in social media cost-per-click algorithms. Let's dive into the basics of this powerful tool. Linear regression has its roots in the 19th century. Sir Francis Galton first explored it when studying the relationships between parents and children's heights. He said the term regression to the mean to describe how extreme traits tend to normalize over generations. His pioneering work laid the groundwork for modern statistical and machine learning models. Here's what we will explore today. Well, obviously, what is linear regression? Then we will be understanding hours studied, then building a regression model, then predicting outcomes, finally visualizing predictions with Python. Also, you can also watch the process of this presentation here. So what is linear regression? I know this looks terrifying, but bear with me. Linear regression estimates the relationship between a dependent variable y and one or more independent variables using the equation as shown, where y is the dependent variable, for example, exam marks. Beta 0, intercept value of y when all x's are 0. The x's independent variables, for example, hour studied, and the Vita's regression coefficients, measure the impact of each x on y. Finally, let's not forget about epsilon, the error, which captures unexplained variability. Hours studied influence exam marks. Let's build a regression. Let's start with the dataset, which actually are my marks and my hours studied. Then we look at the steps. First, let's import the libraries, obviously. Then let's import the data. Based on the equation, marks is equal to Vita 0 plus Vita 1 times hour studied, and let's not forget our error. Let's look at this example. Let's say, for example, you wanted to study 5 hours. Then how much would you get? Well, based on this Python code, which if you press here, ta-da! Well, now what? Well, if you run the code, you get second. Ta-da! Here in the graph generated, the blue points represent the actual dataset, the marks versus hours studied. The red line is the regression line, showing predicted marks based on hours studied, and the green point is the predicted mark for 5 hours of study. The graph highlights how the model predicts the trends as effectively as it can. I know someone might talk about the theory of diminishing results and overstudying, but we will not be covering that today. Error? Well, by using the equation of error is equal to y actual minus y predicted, we can find that yes, there is an error, and it's actually 8.7. Why? A good question. Well, firstly, data noise. In the real world, data points are rarely predicted aligned. Factors like measurement errors, human behavior, or randomness create variability. Secondly, model simplicity. A linear model assumes a straight line relationship which may not perfectly capture a complex nonlinear pattern in the data. And finally, omitted variables. The model might not include all factors influencing the dependent variables. For instance, static quality could also affect exam marks, but isn't part of the dataset, as we talked previously. What happens now? What happens after finding the error? We use matrices like mean squared, the MSE, or the R-squared, which explains how much of the data variability the model captures. Then we improve the model by adding more variables, for example, static quality, handling outliers that distort results, or trying nonlinear approaches. And finally, we validate the model, test on unseen data, use cross-validation for better reliability. The goal is to minimize the error while ensuring the model generalizes well to new data. Linear regression, from predicting marks to modeling countless real-world relationships, it's simple yet remarkably effective. I hope you had some fun learning and actually paid attention to learn linear regression with me. Thank you for your attention.